Good afternoon. This is another in a series of ESA's afternoon technology presentations. This one is on Patran's Composite Layup tool. And I expect the presentation today to be 25 to 30 minutes. We will keep it muted during the presentation, but I will open it up at the end for questions. We will follow up with an email with a link to download the presentation, so that it doesn't clog up your inbox if you don't want it, but you can just click on it and get a secure download of the presentation. And at this point, I will go ahead and hand it off to our presenter, and that'll be Don Trong.
Hello. So this technology session is going to be an introduction of the MSC Composite Layup tool. My name is Don Trung. I'm an analyst here at ESA. And a quick introduction, the MSC Laminate Modeler is an add-on feature to MSC Patran, and is part of MSC's suite of software tools that help analysts quickly construct, visualize, and analyze laminated composite structures. The focus of this presentation is to demonstrate MSC's Laminate Modeler's ability to help the analyst visualize and manage composite layups and apply information. And just to clarify, MSC's Laminate Modeler is an add-on feature. It's not the composite material property that's built into Patran, but is an add-on feature that simplifies the approach and the number of steps needed to create a composite FEM model. Quick profile of ESA. We were founded in 1991, providing advanced technology R&D solutions to clients and develop product development solutions also. Our philosophy is we provide engineering solutions and technologies to our customers. We expand our clients' capabilities using on-demand expertise and resources, product development, prototype, and testing abilities. We provide CAE implementation services and sales using best practices and introduce best practices into the engineering design process. Okay. So getting started, the usual steps that one has to take in creating a composite model is first, we would create a laminate material definition. In this case, we are using a 2D orthotropic ply where we apply the direction-dependent properties. Next, we will use the Laminate Modeler to create the ply, define their orientations and the draping, and then we apply the layups, which consists of the individual plies onto the structure. The next step usually involves running the analysis model and then post-processing. For this presentation, we will concentrate on defining the laminate material definition and using the laminate model to create the laminate model. For this example, we'll be using a composite fairing that has plies on both the top and bottom of the fairing. It is the matte mesh. The fairing consisting of a small slice, actually symmetric slice of the model. Okay. A quick review. A ply is a flat group of fibers embedded in a matrix. The matrix is the glue that is normally modeled as an isotropic material that holds the fibers together. In our example today, we'll be using a tape ply, where the fibers are oriented in only one axis, versus unidirectional plies, cloth plies, where the fibers are woven together and occur or are oriented in multiple directions. So this is an image of the standard Patran ribbon GUI. The first step is that we're going to create the material property in Patran. So we will click on Properties, click on the orthotropic property ribbon, and then the actual GUI itself will pop up. Like most Patran tools, everything is organized into action, object, and method. So in this case, for action, we'll create for the object 2D orthotropic, and for method, manual input. We'll call this tape ply, graphite epoxy tape, with the name shown here. And we will click on the input property button. So we have options for the constitutive model here. So first, we're going to actually make sure we choose the linear elastic model. And here's where we apply the directional properties. In this case, we have X and Y moduli, Poisson's ratio, density, and thermal expansion coefficients. Next, for the next constitutive model, we'll put a failure model in there. In this case, the directional tensile strength of material. And we push OK and apply. And we've created a material model in Patran. So the next step is to go into the Laminate Modeler tool itself. It's located in the Tool tab, and the pull-down menu comes down. We'll choose Laminate Modeler, and then on the secondary pull-down menu, Layup and Laminate. Pops the main GUI interface pops up. We are going to create a new layup file. These files are saved when you use the Laminate tool, and can be opened later and used later on. New layup, and we are going to call this file fairing. Type in the name, push OK, and we get started. So after that, the interface GUI here pops up, and this is where we will define the laminate material from the Patran material that we defined earlier. So the first step is for action. We choose create. For object, element material, and for method, add. We're going to choose the graphite epoxy tape material that we defined in Patran earlier, and we're just going to call it material 1. And this is where we define the thickness. So additional property, thickness of 1/4 inch is applied. Push apply, and we've created material 1. So here's an image of the sample that we are presenting. Please note that the FEM is divided into separate structures, separate surfaces, 1, 2, 3, 4, 5, 6, and 7. And then we have points for reference, point 1, 2, 3, 4, 5, 6, and 7. Just keep note of those points and surfaces, and we will be using those when we define the ply properties. Okay. The Laminate Modeler uses surfaces, points, and vectors to define ply orientation and the applied surfaces, whether it's going to be on the bottom of the surface or on the top of the surface, versus using a global coordinate or a local coordinate system that is normally used in Patran and the properties menus. So just keep in mind that ply orientation is defined from a point using vectors. So nomenclature that should be defined first before we actually create the plies. First is application region. Application region specifies the region of the model where the ply is to be applied. Application point specifies the location where the application of the ply is to begin. Application direction specifies the side of the surface to which the ply is added. So it's whether it's going to be on top of the structure or on the bottom side. Reference direction specifies the direction of the fiber. The fiber may be rotated relative to this vector, and it's used to orient the ply. Reference angle uses the reference direction, and it defines the orientation of the ply direction. Okay. So let's define our first ply. So under Action, we choose Create. Under Object, we choose Laminate Ply, and Method, we choose Add. The type is going to be draped scissor, so it's going to be draped over the surface. And we're going to select the laminate material that we defined earlier, which is mat 1. And the next step is to define the area of application. So here, we're going to define it on surface 1, 2, 3, and 7. And it's going to be applied on the underside of the sample fairing. So the next step is to define the start point of ply direction. We're going to choose point 1 here. And note the application vector. The ply is going to be applied on the underside. The vector application direction is going to designate the location or the orientation of the ply. I'm sorry, not orientation, the location of the ply, whether it's going to be on the top of the surface or the bottom of the surface. If the vector is pointing to the bottom of the surface, as in this case here, the ply will be applied to the bottom surface. If you define a vector that points to the top of the surface, then the ply will be applied to the top of the surface. And then the next step is to define the reference direction. If the vector here is defined in green, we're creating a point from point 1 to point 2 that defines the reference direction, and that designates the orientation. And then reference angle is going to be 0, which means that the X direction of the ply or extra material direction of the ply is going to be oriented in the same vector as the reference direction. Push apply. So we've created a material or a ply layer on the underside of this fairing. The next step is we're going to apply a ply at the same locations, but at a 45-degree orientation angle. The exact same inputs stay the same, except the reference angle is set at 45 degrees. Push apply, and this is the result. And as you can see, another ply with this orientation is applied. The exact same process is used to define the other plies. The same steps, except selected area and orientation angle will change. So let's just define the other plies here. So ply 3 overlies or drapes the ply on the underside or the opposite side of the fairing. So again, Action, Create, Object, Laminate Ply, Add, Type, Drape, and we're going to select the same material. In this case, we're going to select surface 4, 5, 6, and 7, which is on the opposite side, and we're going to apply it on the underside also. Here. Reference angle is going to be 0, and all the other inputs is obvious. So we're applying that ply on the underside as indicated here. For ply 4, the exact same location and inputs, except this one is going to be at a 45-degree orientation. All the inputs remain the same except reference angle. Push apply, and ply number 4 is in place. For the rest of the plies, we are going to apply them on the top surface of the fairing. Okay. So we're going to pick surfaces 1 through 6, which are all the top side surfaces. We're going to clear the contents of the application direction box. By default, the MSC Laminate Modeler will apply direction on the top by default, or you can put a vector pointing to the top side of the surfaces. But we're going to leave it blank and let the default do its job. Reference direction is going to be from point 1 to point 2, and reference angle is going to be 0. Okay, ply 6 overlays ply 5. Everything remains the same except for the reference angle. So we're applying a 45-degree oriented ply over ply 5. The remaining plies add more material to the top of the fairing. Ply 7 overlays ply 6 over surfaces 2, 3, 5, and 6. Okay. And as the other first plies, we have a reference angle of 0. And apply. We're going to apply the same surfaces again with apply, except another 45-degree orientation. All the inputs remain the same except reference angle. So that will be our ply number 8. 5, 9, and 10 are draped over sections 3 and 5. The exact same process, where the first ply is 0-degree reference angle, and ply number 10 is the exact same with a reference angle of 45 degrees. Okay, so now we've defined all the plies we want to use in our model. We can check the plies in the MSC Laminate Modeler by choosing Show for action, Object is Laminate Ply, and Method is Graphics. And we could choose each of the desired ply, and it will bring up a graphic representation of the ply, the direction of the ply, the orientation of the ply, and the application surface of the ply. So ply 10 is applied on the top surface, and hence the application vector. It's oriented along this green reference vector, and it's occurring over surfaces 3 and 5. Same thing for ply 1. It is applied on the underside, hence the application vector on the underside of the fairing. Reference angle and orientation is along the reference angle and is applied on the surfaces indicated here. And so on and so forth for plies 4, ply 7, ply 9. Okay. So after we define the plies, we will define the layup. So action is going to be create, object is LM layup, method is add. By clicking on the layup definition button, your layup GUI pops up. These tools on top are different tools for adding, subtracting, and orienting, and so that could be used to define your layup. We won't be going through that on this session, but you guys could explore it yourselves. So we will select plies 1 through 10 from the existing LM ply list down here. When you use the tool, the sequence of the ply occurs in the sequence that we bring up the plies. So ply 1 will be applied first, then 2, 3, 4, 5, 6, and so on. You can change the order of plies by changing the order in the list here, but for now, the way we define it is the order of the plies we want to apply them. Push OK. And then we apply the laminate or orientation, as indicated here. And we're going to choose angle as the option. And push apply. A quick message window will pop up listing exactly what you've done, and you're going to push yes to accept. Okay, so you've created your plies or your laminate plies. To show the layup, action will be show, object will be laminate layup, and method will be exploded view. We're going to select fairings 1 through 10, push apply, and it will provide you with a visual representation of what you just done, your laminate layup. Okay. So that completes our quick introduction to the MSC Laminate Modeler. It's a tool that emulates composite structure construction by allowing you to define easily the ply material definition, the ply layup sequence, the ply orientation, stack verification, and visualization. It's quite a bit more easy to use and more intuitive than traditional method of applying properties in Patran, where it's a manual process in defining orientations and material directions. Okay. And that completes our technology session here. I will open up the lines for any questions. Also on the screen are our contact information, mine, Don Strong's, and Martine Martinez's. Please feel free to contact us. The reason why we chose to do the Laminate Modeler for this session is because we were shown interest, or someone has actually requested for us to review or introduce the Laminate Modeler since the last session. So if you have any input or any suggestions on something in the future that you'd like to see, just let us know. So I am going to turn off the presentation mode, and open up the session for any questions. Okay, so are there any questions? Okay.